Today we'll learn about the architecture of RISC, RISC 5. And have you guys, do you guys have any idea about the RISC architecture before? थोड़ा सा भी कुछ भी आता है?
No, sir.
No, sir.
Okay. Uh, Anyways, we'll start. Any idea about what a processor do? Have you heard about CPU is called the brain of the computer, right? So what basically happens, whatever code, whatever actions that a computer takes, or a phone, let's say anything, the processor drives all the actions, right? Whatever code we write, but what happens is, it loads the instruction first, right? And then it figures out what operation that we have to do, what data we have to use, and then it does all kind of computations. Fine. So I'll tell you what finally we are going to do, like the kind of architecture that we are going to build. This is the final architecture that we are going to build. Is the RISC architecture. It's not possible to do all the architecture at once. I'll do half of it today. Okay. We'll first do arithmetic, right? Which is basically the add, subtract, multiplication, load, store, and then we'll go to the control flow. So starting with are you guys comfortable with Hindi also?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Maybe I'll switch to Hindi sometime. क्योंकि कुछ चीजें टेक्निकल चीजें हिंदी में बेटर होती है. So as you guys said, it's completely new to you. I'll first give an introduction of what is an instruction, right? In a computer architecture, instruction is a binary coded operation code that specifies a particular operation. So let's say we have to do addition in a computer. Fine. So for addition, what we want is the computer should know that we have to add. We want our data, and we should know that in which register we have to store the result of the addition. So this is the basic format of an instruction. See, it's a new thing. शुरू में थोड़ा लग सकता है कि थोड़ा complicated है, but try to be patient with me. This is a format of an instruction. Fine. This is basically a combination of zeros and ones. Computer cannot understand if else. Computer cannot understand. Just a minute. Where is my Zoom? Okay. Sorry. Yeah. This is a combination of zeros and ones. Computer cannot understand if else for loops. Everything that we write in a code that gets converted into this zeros and ones, which we call as a machine language. So let's say we give a command that, okay, you have to add two numbers. Fine. Let's say R1. Okay. R1, R2. The very first, this is a 32-bit instruction. Fine. This is a 32-bit. This is 31 से लेके 25. Then 24 से लेके 26 actually. From 25 to 21. Then 20 to 16. Then 15 to 11. So the bits from the 31 to the 25, this is called opcode. Fine. Have you heard about opcode before? थोड़ा सा भी कुछ भी कभी सुना है?
Yes, sir.
हाँ. So what opcode does is, opcode basically tells what to do. करना क्या है हमको? Add करना है, subtract करना है, multiply करना है, load करना है. Fine. Whatever we want to do, opcode tells us. This first 6 bits of an instruction tells us what exactly the computer has to do, right? So, for example, I'll give a very small introduction. Let's say if there's a code, fine. If थोड़ा बहुत C तो आता है ना?
Sir.
Okay. If A equals to B, C equals to A plus B, else C equals to A minus B. Fine. So computer cannot understand this human language. Oh, I'm sorry. I'm sorry. What is this happening? Computer cannot understand this human language. This is A plus B. इसको ये 0 and 1 के फॉर्म में मिलेगा, ठीक है? This addition, this plus is our opcode, right? This itself is an instruction. This is telling that okay, you have to add two numbers which are stored in register 1, register 2, and we have to store it in C. But computer cannot understand this plus sign or anything. It understands only 0 and 1. For that, we have an opcode. This opcode tells us what exactly we have to do: add, subtract, multiply, load, whatever. Okay. So the second two sections of an instruction. First of all, this is 32-bit instruction. Okay, this 32-bit instruction is divided into different sections. The first 6 sections is opcode. Second 2 sections are our operands. Fine. This ये थोड़ा सा गंदा सा हो गया है. Sorry for that. ये this 25th to 21st. This 25th to 21st bits are going to tell us about the first operand, which is basically the address of a register. This thing is going to denote an address of a register, which is going to, let's say, contain a certain data value. Fine. This is the second operand. This is our second operand. Fine. Which is our R2. These two are called operands, and these are the address of the operands. We'll dig deep into this and we'll understand even better. But for now, let's try to understand the format of the instruction. And this 15th to 11th bit, this is our destination address or destination register's address. Fine. So these are the three sections here. These two are called operands. These two will contain the operand registers. Which operands मतलब पता है? Operand मतलब when we do R1 equals to R2 plus R3, these two are called operands. मतलब we are performing the action on these two registers. Fine. And this is called our destination register. We are performing the operation on these two registers and putting it back in this particular register. This whole action will be done by this processor. Fine. I'll tell you how the exact architecture works, and we'll build the whole architecture. But before that, try to understand what kind of instruction that we are going to follow. So this was about the arithmetic. This was a format of an arithmetic operation instruction. Fine. एक और instruction होता है load store. उसका थोड़ा सा इससे अलग होता है. I'll tell you about that. The final 11 bits. Okay, the final 11 bits is the offset value. Offset value का काम addition में, arithmetic में नहीं भी काम आ भी सकता है. This offset value basically contains some sort of data which we are going to use in the ALU for address calculation or for jumping in a particular sort of address. Anyways, ये शायद अभी समझना है. When we'll do load and store, उसमें ये और अच्छे से clear हो जाएगा. Any doubts here in this format of instruction?
Hello, sir. Hello.
Yes.
Sir, this instruction format is only valid for a 32-bit RISC processor, na, sir?
Yes. This is only valid for the 32-bit RISC processor. See, 32-bit RISC processor going to have a 32-bit instruction. Fine.
Okay, sir. Okay, sir. One more thing, sir. Sir, we have heard about ARM processor, Intel series processor, AVR processor, something like that. And we have also heard about RISC processor, CISC processor. On what basis they are actually classifying this processor, sir? On what are the main basis they are considering while doing this? What is the main RISC and how RISC processor is different from ARM processor or Intel series processor? Is it a broad category or...
It's a factual thing, but as per my knowledge, ARM processors are based on RISC processors. ARM processors use the
Okay.
RISC processors. They use RISC processors as an IP. Do you have any idea about IP?
Yeah,
intellectual
I have some
property.
idea, sir. Yes, sir.
Yeah. Tell me.
Synopsys, ARM, they will be providing
Yeah.
IPs for the chip designers.
Yeah. They use RISC processor as an IP. Fine. And
Okay.
उस RISC processor को वो लोग use करके अपना ही कुछ they do custom design it. Fine. And they
Okay.
build something else out of the RISC processor, but they use the RISC processor inside their processors. And about the
This is
CISC
why.
processors, RISC processors are exclusively used in the computers. For now, which I know, RISC processors with the mobile, RISC processors are actually very fast than the CISC processors.
Okay.
They,
Okay, sir.
they are much faster than the CISC processors. And the reason of this fast is, I guess, it's about being able to access the memory in such a way. I have to look
Pipelining, I
into
think,
it
sir.
actually. I have to look into
Pipelining
it.
we can do in the RISC processor, no, sir?
By planning.
Pipelining we can do in the RISC
Pipelining,
processor.
pipelining, obviously. Pipelining has to be done. This is the non-pipelining thing that I'm going to explain. But when we introduce pipelining, it actually becomes 10x, 40x faster. So
Okay, sir. Thank you, sir.
when we will understand pipeline, when we will study pipelining, we will be able to understand that.
Okay, sir. Thank you.
Sir,
So before that, you have to.
I'm sorry. Hello.
Yeah. Hello.
Yes, sir. Sir, I just have one more question. So when we talk about the RISC processor and a CISC processor, right? Do they have a completely own instruction set of architecture to decode those instructions? I know like the pipelining is basically present in the both of the structures, but do they have individual ISS so like they can easily decode the instructions?
Individual ISS.
Yeah,
I think
so ISS,
basic
instruction set
ISS
architecture.
they are anyways going to have like this add operations, load operations, store operations. These are the common ISS which both the RISC and the CISC processors are going to have. Beyond that, there can be some different ISS which they have to have, because see, CISC processors are completely exclusive to the computers. Fine, they have a different sort of architecture. They use the memory in a different way. RISC processors are much faster than that, and one more thing, I think the number of instructions in RISC processors are lesser than CISC processors. This is one thing I know.
I think it should be more, right? Because like it's a reduced instruction set of architecture, but the instruction will be more, but the complexity of the instruction must be less, right? In the RISC one.
Yeah. RISC processor is less complex.
Okay.
Much less complex, but and the number of instructions are also going to be lesser. See, that's a computer and it's a phone. This processor phones में use होते हैं. ARM processors ये सारे phones में use कर रहे हैं. And the CISC processor is going to be used in the computers.
Okay.
So the number of instructions are going to be much higher. Instructions क्या है? Instructions basically are going to tell what are the different number of operations that you are able to do. Fine.
Yeah. Yes, sir.
So computers, if you compare a computer with a phone, even though these days दोनों को काफी पास ले आने का कोशिश किया जा रहा है, but still computer is much has a heavier set of instructions. But if you want, I'll tell you about the difference between CISC and RISC. I have to go through that in a very better way.
Okay.
So I'll be able
sir, I got it.
I think I have some notes also.
Sir, oh yeah.
Yeah, tell.
Sir, like I'm new to this one, sir. Is there any like prerequisite we need to know to grab your concepts, or you will be teaching from basics, sir?
Prerequisite. See, if you do you know read write operations?
Yes, sir. Computer
You know
architecture,
read write
I know a
operations.
bit, sir. Yes, sir.
Okay.
Computer architecture I can handle well.
Okay. Then it will be very easy for you if you know computer architecture.
Okay, sir.
If you know do you have about read write? You have idea about ALU? You have idea
Yes,
about
yes, sir. Yes, sir. Yes, sir. I watched the lectures, sir. Yeah.
Okay. See, RISC is nothing. See, these are the different kind of components which are there in RISC. Fine. We are going to combine these components, and I'll show you. These are the different kinds of components that we are going to individually. Do you know all these things, right? You know what is a mux, you know what is an ALU,
Yes,
you know
yes,
what is a memory, you know what are registers. We
yes.
read something here, we read the data from here. We are going to use all these components to build our final processor. That's it.
Okay,
So,
sir.
and one more thing, it will be very good when we will understand branch and jump instruction. Do you know if else operations, for loops, jumps?
Yeah, yes, sir.
It will help you to relate better the execution of the uh, code with the hardware implementation. बेसिकली
Yes.
हम जो भी लिख रहे हैं ना कोड में, वो पीछे हार्डवेयर में इम्प्लीमेंट हो रहा है. ठीक है, इट्स नॉट जस्ट द कोड. इट कंप्यूटर टेक्स द मशीन लैंग्वेज and the entire it gets implemented in the hardware, and then only we get the result. Fine. So we are going to study the implementation of the code or the small instructions which what we call in the hardware. Okay. I think इस पर्टिकुलर इंस्ट्रक्शन में कोई डाउट है, बिकॉज दिस इज वेरी इंपॉर्टेंट. ये नहीं समझ
Sir,
आया तो आगे दिक्कत हो जाएगा.
sir, am I audible?
या श्योर.
Sir, so in this 32-bit instruction sets, you divide it into like opcode, offset, and two operands and one destination address. Sir,
Yes, yes, yes.
what if, sir, we have operands more than two? Then what will be our instruction sets?
Operands more than 2.
Yes, sir.
See, what happens is, let's say this particular thing, these two things get added, fine, and this thing gets stored here in the R1, and we have a third operand. The third operand, this will now act as a operand now, this destination register. Because what happens is, let's say,
Yes, sir, like we do in microcontroller.
let's say this is a register file, fine. This is R1, this is R2, this is R3, fine. See, first of all, these processors are very fast, so you cannot say ये दोनों add हुए, fine. These two get, oh sorry, what is happening here? These two are getting stored in the R3, right? And hello.
Yes, sir, audible, sir.
Yeah. And then in the next cycle, this R3 will be accessed as an operand, right? And will be added to will be added to R1 plus R2. Now what is R1? This is a bit confusing. If there's R4, these two get stored in R3. I think I have a half idea about this. Maybe I'll have to look at it. Is that okay if I let you know after the class?
No,
sure,
issue, sir. No issue, sir.
Because what happens, what the half idea which I have is, see, when R1 and R2, when it gets calculated, it gets stored in the R3. The same R3 is a register, right? We can use the data of the R3 in our next instruction, right? So it gets added to the R1 and R2 in the next instruction. But where does it get stored? That I think maybe let's try R1 plus R2 plus R3. This R1 plus R2 gets calculated, right? In the first instruction. This is the first instruction. In the second, it will get calculated and get stored somewhere, right? Maybe R dash, maybe in R dash register it will get stored, and that from that R dash register, that will again, that this R, now it will be like R dash plus R3, This is our instruction 1. This will be our instruction 2. This R dash will be added with the R3, and now it will get stored to the R4. See, there are lot of registers inside the register file. Fine. And we calculate each and every result and put it in some register, and we use the data of that particular register in the next instruction. So the destination register which is there, we can use that as a as an operand. We can use the data of the destination as an operand if in the next instruction. I think this much I could understand.
Sir, these intermediate calculation, I think, must be stored in the accumulator. So is it like that key this R1 plus R2 will get first stored in accumulator, and then we can use R3 to add to that data, and then finally store the.
It may be like that. See, I have to see the intricacies of that particular architecture, which has all the accumulator and all. But this is on a very surface level. I'm trying to understand that if there are many registers in a register file, right? We are adding two data and putting that data in a particular register, and for the third, that's let's say R dash. हमने R1 और R2 को add करके हमने R dash में डाला, and then we added the R dash value with the R3, and finally in the destination register was R4, and we put the R dash value and the R3 value in our destination register. So the concept which you need to understand here should be like that every register in a register file, it can be used as an operand also, as a destination register also. So whatever result which comes back in the destination register, it can be used as a data or as an operand for our next instruction. But anyways, I think this was not the correct explanation of this. Maybe I'll let you know. So this was the instruction for the arithmetic operations. Fine. Now I'll tell you about the instruction format of a load store operation. For load store, the first six bits are going to be our opcode. Right. The second, let's say we call it as R2, and this will be our R1. ये 31 से लेके 26 25 से लेके 21 20 से लेके 16th, and this offset will be of 16 bits. Fine. So what happens in load store is, those who do not know read write, यहाँ पे समझ लो. Let's say in a memory, this is our address, this is our data. Fine. This is let's say R1, and it has a data of 64. So while loading the data, what happened? While loading the data, it's like ये हमारा मेमोरी है. R1, sorry, this is R2 actually. R1 will be equal to mem of R2. This is what we call loading of a data. We go to a memory, we access the address of a particular data, and this becomes 64. Fine. Any doubt in this? This is how the load takes place. Storing of a data, I'll show you. Let's say हमारे पास एक और register है R4. Fine. And this is a vacant space. And we want to store the value of R1 in R4. So first we will access mem of R4. Fine. And we will put the value of R1 here. So what will happen is, जरूरी नहीं R1, it can be any data also. It can be any data also which we are getting calculated from the ALU or from the register file we are taking. Fine. So mem of R4 will become here as 64 or any data. The difference between the arithmetic instruction and this is that the first 6 bits are going to act as opcode, right? This opcode can be anything. 0, 1, 0, 0. Okay. This will tell us whether we have to do load, store. The third is going to act as our destination, these bits. Destination register's address. Okay. For store operation, let's say for store operation. And second, and this R2 is going to act as an operand. So can you see the difference between these two format of instructions? For arithmetic, these two are acting as operands, and the 16th to 11th, this is acting as a destination register address. For load store, the 20th to 16th bit is acting as a destination register, and this is acting as an operand, and this one will be our offset. What offset does is, let's say we have to add something to the address. मान लो मैंने 64 add कर दिया, ठीक है? So it's like this. Load R1 64. I'm lagging actually. 64. So this will be R1 mem of R2 plus 64. Fine. This offset is telling us that what address that we have to add to our address, right? We have to add 64. Basically, 64 into 4 hona chahiye. But this is address unit. We are adding 64 to the current address, and then we are loading that from the memory, and we are putting. So for example, let's say यहाँ पे this is R2. Okay, this is R2. And in R2 we are accessing this R2 register, and we are adding 64. So it will take the data from here where the address is R2 plus 64, and the corresponding data of R2 plus 64, it will give to the R1. So this was the format of load store instruction. To repeat again, the first 6 bits are opcode. The second is our operand, where we have to read or write. The third is the destination register. Destination register. We basically we either write in this address or we load from this address. So any doubts here? ये दोनों clear है ना? Are these two instructions are clear? These two. Okay.
सर ऑफसेट का काम जो आपने बताया एड्रेस में एंट्री मतलब एड्रेस में कुछ ऐड करने का, बस वही होता है कि और इसके अलावा और कुछ भी होता है?
यही होता है for now, for load and store यही होता है. For branch there's one more thing called skip label, but in branch also, let's say you have any idea about jump instruction or branch instruction?
Yes sir.
Okay. Jump branch instruction में क्या होता है? Let's say BEQ R1 R2. Let's say there's some label here, but let's say अभी के लिए label नहीं, I call it a address. Let's say address is 122. So branch equals to instruction में क्या होता है? If let's say A equals to B, we do C equals to A into B, else we do C equals to A minus B. So in branch instruction, this is our R1, this is our R2. It compares both of these. If the result of these two is equal, then we go here. If it is not equal, then we go here. So this going to here, this thing, the address of this else is given here, right? 128. Is that clear?
Yes sir.
Branch basically tells you कि compare करने के बाद कहाँ पे जाना है. Let's say अगर ये नहीं हुआ equal to, jump का भी same scene है. Jump का for example there's something जिसको समझ नहीं आया कोई, इसको ये समझ नहीं आया कोई दिक्कत नहीं, but I'll give you a example. Let's say there is a for loop and you write something, ठीक है, कुछ भी चल रहा है, and here we break. Any idea about break? किसी को भी थोड़ा सा?
Yes sir.
But break does this, break it will just terminate the for loop, right? पहले क्या हो रहा था? It was just looping. Instructions चल रहे थे, ये loop हो रहा था, fine, कुछ भी हो रहा था. But when you do, it breaks out of the loop. This is called jump. We are jumping to a particular address, right? हम यहाँ पे jump करके बाहर निकल आ रहे हैं. We are not going back. So where we are going, in which address we are, maybe we are going to a particular function. No, basically break करने से हम for loop के बाहर ही आ जा रहे हैं. So after breaking the loop, where we have to go, this particular address is going to tell us that where we are going to go after breaking the for loop. So this is how computer takes a break statement. It jumps to a next address. Even here also, let's say if this if gets successful, let's say if gets successful, आइडियली क्या होना चाहिए? आइडियली सीक्वेंशियली एग्जीक्यूट होता है ना, कंप्यूटर में सारे कोड्स होते हैं वो सीक्वेंशियली एग्जीक्यूट होते हैं, पहले ये होगा फिर ये होगा फिर ये होगा फिर ये होगा. तो C इक्वल्स टू A इंटू बी, C जब A और B को कैलकुलेट कर लेगा, आइडियली एल्स में जाना चाहिए, बट it will jump. It will not go to the else part. It will jump out of the if else statement. So ये थोड़ा सा jump और branch instruction का overview था. So these two formats are clear because in architecture it's very important that you understand the format of addition, arithmetic instruction and the load store instruction. Okay, मैं store भी बता देता हूँ. Store, I think I told you, right? When we have to store something, mem of that particular address, we give the data over here. In load, we take the address, we put the address in the mem, we take the corresponding data and we put it into the register. Fine, this is load store. Okay, moving forward. I think I already explained this. Okay. So this is reg file. Okay. I already gave an idea about this, but इससे मैं फिर से दे देता हूँ. Yeah, we'll do it. We'll do it in the next one. So what does a RISC? What are the things, components of a RISC processor? RISC processor are going to contain registers, adders, arithmetic operation, arithmetic logic units, multiplexers, register files, program memory, data memory, and bit manipulation components. Fine. Let's give some overview about how this register file works. Fine. मैं थोड़ा सा इसको स्टार्टिंग से बता देता हूँ. So in a register file, this is our register file. We have ports. Fine. The first port is read address 1. The second port is read address 2. The third port is write address. The fourth port is write data. Here, it's very easy. It's not difficult. Okay. And there are going to be registers in the register file. Fine. There are going to be many registers. ठीक है. यहाँ से let's say कोई address आया instruction से. Fine. There's a instruction memory. That 32-bit address that I told you, right? That 32-bit address. This is 32-bit address. This is the same format. The opcode will go to the controller to tell that what we exactly have to do. Add, subtract, load. So we can. From here, the 20 INS, let's call it INS, 25 से लेके 21, it goes to the RAD. Whatever address it comes here. Let's say 1010 कुछ भी आया, ठीक है? It will take that address, this corresponding address. It will go to the corresponding register to which the address denotes. Let's say इस particular address में हमारा रखा हुआ है 28. Fine. And this is read data port. Fine. We take the address from instruction memory, go to that particular register, take the data from here, and बाहर हमारा यहाँ